My name is Underwood. I'm from the University of Essex. I'm chairing the science session. That's what this session is called. So it's really great to have a session on the latest science that's going ahead. One of the roles I share with Joe Preston actually is chair of what we call the Connector SIG, the Connectivity Special Interest Group. And that was something that was set up, I think mainly with Roger Proudfoot's sort of initiative, but with Roger and the Estuarine Coastal Shelf Association to draw together a place where scientists, academics working around coastal systems could interface with the agency and some of the challenges that the agencies and other partners face around what we don't know about these systems that we love so much. So the Connector SIG was set up about 2 years ago. I think Joe mentioned it at the ReMeMaRe meeting last year, actually. And as part of that, we identified 5 theme habitats. Well, 5 theme habitats had been identified anyway. So seagrass, oyster beds, kelp forests, mudflats, salt marsh. And we tasked a set of people to sort of go ahead and pull together their community to really look at some of the questions we still needed to answer around some of these science knowledge gaps. And we have some of those champions here today to tell us a little bit about that. So we have 5 speakers today linked to that Connector SIG work. We have Mark Parry from Ocean Conservation Trust, who's going to talk about seagrass, Angus Garbutt from UK CEH, who's going to talk about saltmarsh, Bill Sanderson from Heriot Watt University, who will talk about oysters, Pippa Moore from Newcastle University, talk about kelp, and then Joe Preston from the University of Portsmouth, who's going to talk about connectivity and how these key habitats interact in our coastal zones, really important for thinking about restoration going forward. So each speaker's got 15 minutes. With these slightly longer talks, we're not having a question and answer session, but we are have the option to put questions to them through the Sligo app. So if you'd like to put specific questions to our 5 speakers, please put the questions on the Sligo app, and then the organisers will make sure that those get through to the relevant people. And I guess we'll also chase up to make sure they answer them as well, rather than just falling into the email void that we all experience. So either do questions through Sligo or catch them in the drink session and things afterwards. So after the 5 talks, we've then got something new. We've got 30-second flash talks from the poster presentations to whet your appetite and help you identify which posters you want to go and talk to later. And that's going to be choreographed by Roger at the end. So we've got a set of talks, then Roger's choreographing these flash talks, and then we go to the drinks reception, and the evening moves on in its normal way. So thank you very much. Thank you to the speakers for agreeing to come and talk to us in this science session. And first up then is Mark Parry from the Ocean Conservation Trust. So thank you, Mark.
Okay, good afternoon everyone, and thanks for having me along to talk this afternoon. So I've been invited to talk to you about the state of UK seagrass science. And for those of you that do not know the Ocean Conservation Trust or myself, I'm the head of Ocean Habitat Restoration. We run our own programme through Blue Meadows, which is involved in protection and delineating and marking where these fragile habitats are, or fragile seagrass habitats. We're involved in active restoration, and we are involved in, and we're just about to launch a donations-based voluntary sort of credit scheme for seagrasses, because as we've heard, there's a huge amount of work that needs to take place before we get to a position where official credits are acceptable. So we are going to we're in the process of developing a donations-based model. We also work with Life Recreational Remedies, which is an EU-funded project, and Duncan spoke about the significance of that this morning in one of the keynotes. And we are responsible for the restoration and education elements of that project. So we've also been described as a group of underwater gardeners, which is certainly not the worst thing that I've been described as. Yeah, this is taken from Devon Life in the June edition. So team team and myself, we spend a lot of time on the water. So what I've been asked to do, and what I'm going to try to do over the next 15 minutes, is give a summary of the proceedings from the inaugural Seagrass Symposium held in Plymouth at the National Aquarium last November. Now, there were 9 organising committee members, there were 7 chairs, there were 35 speakers and 150 delegates. So I've got a lot to get through in the next sort of 15 minutes, and if I've misrepresented or haven't included any of the significant points that some of the speakers and the attendees wanted covered, then please come and grab me at the drink session. So the sessions included ecology and function, threats and protection, the massive amount of work that's done by the community in this space, mapping, monitoring, understanding the extent and health of these areas, huge amount of restoration work, both intertidally and subtidally, ecosystem services, and one of the subjects that we've already spoken about this morning, which was financing. So, seagrass ecology and function. I think everybody is under the agreed position that seagrass meadows are not all equal in ecological function. Most provide ecosystem services, but they don't have a linear relationship with each other. So if a bed is dense, healthy, and has a great deal of coverage, then that might provide a certain ecosystem service, for example, an uplift in biodiversity, but that doesn't necessarily have a linear relationship with its carbon sequestration capacity or its nitrogen stripping capabilities. And I think that really comes down to some of the environmental factors. So seagrasses cover a broad range of environmental conditions within the UK, lagoon, estuarine, coastal. So when we think about ecological function, we have to think about where these meadows are positioned. And in tandem with that, then each one of these sort of geographical areas have different drivers for recruitment, for health, and they can include salinity, light, temperature, bathymetry, and sediment classification. So there is a complex relationship between the ecosystem services and the environmental factors that need to be considered. And the current statutory advice is that or the aim for the future is that 73 protected sites for seagrass are in favourable condition. Now, the driver from Natural England, or the statutory advisor on conservation, is that there is an uplift in biodiversity with this recovery. And there was an interesting question this morning about when will these habitats just be seen beyond planting plants and ticking that box. And the statutory advice presently and moving forward presumably would be that the driver is to increase biodiversity of these coastal systems. The final point that we discussed within the ecology and function is that seagrasses are quite interesting in the sense that they've undergone an adaptation within the cell wall that allows them to deal with salt environments. It allows them to remove the salt and the water passes over that cell wall, whereas other coastal habitats, mangrove, salt marsh, have learnt or adapted to deal with this salt. Now, that's particularly interesting because if we can understand that adaptation, then it opens the field of, or it opens exploration into all sorts of other agricultural applications. And it surprises me that not more plant scientists are involved or interested in studying this adaptation. So there is a dream that when considering that we could end up with hydroponics used to fertilize our agricultural crops. As I said, there's future recovery is a focus on biodiversity, and one of the things that we can all agree is that seagrasses have a lot of important roles, and some of the things that we've spoken about this morning is quantifying those with high integrity to drive investment in recovery, restoration for those habitats. But we are losing these fragile habitats whilst we try to understand how we value those. So we should just crack on and restore them and gain those ecosystem services. And as I say, there is different sites have different drivers for recovery. So threats and protections, seagrasses exist in areas where there is low levels of nutrient enrichment and other contaminants in regions of high water clarity, and they act as a barometer for our coastal waters. And they're fragile to environmental change. One of the things that we discussed within this meeting is that to water quality, eutrophication is more detrimental than the physical disturbance through dredging. So some things to consider moving forward about how we address our protection and how we address our restoration sites. Industry-sponsored programs are returning positive results in successful trials in protection and planting programs. Now, it's fantastic that this funding's coming forward. However, the funding can be short-lived, and to really address some of the unknown and the issues about uncertainty, we need long-term funding, which was something that was discussed this morning, to reverse this environmental degradation. So large-scale initiatives such as EU Life Remedies, as well as other NGOs or NGO initiatives, are working to change social values, create positive pro-ocean behaviours, and take concrete conservation actions and turn the tide on degradation or deterioration. Now, one of the outputs that we'd like to do, and quite commonly we discuss, and that's about knowledge sharing and sort of best practice. And I was travelling here with a colleague yesterday, and we discussed about the value of putting these down within a document. Now, I thought about if I bought a book on how to, for example, build a house. There might be some technical details in there about how I build a house, but I don't necessarily have the skill set to be able to do that. So we need to think about how we share the knowledge that is being created within this space. Some of the industry-sponsored projects, there's some fantastic examples of AMS providing an engineering and ecological solution in Plymouth, showing 212% increase. This learning through remedies, and I think we really do need to consider how we share this learning and how we pass on these practical skills, because certainly reading a book about bricklaying doesn't qualify me as a bricklayer. However, if we think about investing in young people, investing in skills, investing in hands-on development, then we might be able to pass on some of the learnings of these projects. And yes, the point of water quality being one of the most impactive elements of on our seagrass meadows coastally also needs to be addressed. I'd like to just take some of the chair's notes from the UKSS. And when we're thinking about threats and protections, we should stop viewing humans as we should view humans as part of the ecosystem and move beyond viewing humans as the threat. These ecosystems can be and should be used to fish, snorkel, explore, access as a safe haven. And some of the discussions that we've currently had is that anthropogenic pressures are causing some of this degradation, but we need to try and turn that narrative to coastal stewardship. And where networks are in place for communication and communication is sound, there is a shift in communities of self-policing, boaters educating boaters, all stakeholders sharing knowledge through stories, educating each other. These things are already happening, but we need to scale this local stewardship for long-term and inherent sustainability practices. That was taken from one of our chair's notes, which I think is a fantastic example. And that's probably evident in the volume of community work and community conservation that's actually taking place in this space. There are armies of volunteers mobilising to contribute where possible to the recovery of nature. I remember 10 years ago standing in front of audiences and talking about seagrasses being the ugly duckling of marine conservation, whereas now they're a hot topic, certainly within sort of social and coastal community spheres, and there is a drive towards recovery of these spaces. And interestingly, how that narrative have changed. Seagrasses are the only habitat that has its own United Nations Awareness Day. So there is no Rainforest Awareness Day. There is no 3 minutes left. Jesus, okay. Sorry. Volunteers are developing technical skills, habitat restoration and monitoring, valuable to the long-term health of these ecosystems. Seagrass science provides a positive impact on people's lives and mental well-being, providing a mechanism to manage climate anxiety. Community cohesion is expanding, and some threats are becoming to be managed by the community. These efforts are evident in the volume of projects and the expanse of projects over the UK. They're happening on the south coast of England, up onto the northeast, to the west of Scotland, through the Channel Islands, and on the Isle of Man. So, mapping and monitoring. Mapping is beyond the assessment of condition and conservation status and informs decision-making process. So, we need to understand where these habitats are, where the impacts lie, to allow decision-making in marine development and investment in protection and restoration. There's drives for efficiency within mapping and monitoring, using existing echo sounders technology applied to marine surveys. These are reasonably simple pieces of marine equipment that have been applied to mapping extent with machine learning. Shorter acquisition time equals increased efficiency and removes the requirement for good water quality. And environmental DNA allows us to assess the biodiversity of function and habitat from the smallest amount of water, which is allowing us to make these assessments. What does that translate to on the ground? So using these type of technologies, in Cornwall, two huge seagrass meadows were found. There is the creation of the national seagrass layer, which these technologies have contributed towards and made these spaces easier to monitor. And as I say, the sort of development of machine learning and a bioatlas for joint for the IUCN. I haven't even begun to start with restoration, so how long have I got? I've got 1 minute. Okay. So, less than 30 seconds. So, restoration into the catalysts for expansion will work in the ocean environment if it's not degraded. Methods depending on various factors. So, when we think about these ecosystem services and these environmental factors that contribute, then methods are by understanding what it is we're trying to protect and the environment that we're trying to protect it in, then there's various different methods in restoration. Suitability model drives that approach, the application of low-cost methods and sea dispersal is being tried around the UK, and then decades of terrestrial decades of terrestrial planting have developed. I'll just do one more slide, please. One more slide. So sea broadcasts from packages that are 100% biodegradable materials are shown positive in the intertidal, and there is a massive volunteer effort in this. Ex situ growth has now become commonplace. I remember going to Kew Botanical Gardens over 10 years ago, and they were harvesting seagrass from the strand line and keeping it, whereas now we can grow it and understand and perform more experimentation understanding. The microbiome is not understood, but more work needs to take place. Techniques are being shared and adapted with each iteration where we evidence greater success. And I suppose I should conclude that with all of this work, then there should be a process of automation. Creeps up on you. Thanks.
Thank you, Mark. Very big ask to get someone to compress a whole conference into 15 minutes. When you're talking about something you love, the time just flies. So thank you very much, Mark. We move on now to Angus Garbutt from UK Centre for Ecology and Hydrology to give us an update on salt marsh work. Angus.
Thank you. Well, I've got the same job to do. I'm reporting on a conference, a 2-day conference we had in Dumfries last month. And I chair the UK Saltmarsh Forum, which has been running since 2009. When it started in 2009, we had about 10 people there, and it was manager realignment time. That was quite big, but we only had a few people really interested in salt marshes. And since 2009, it's grown and grown and grown to the point now where last month we had 120 delegates and 49 talks, which we tried to cram into 2 half days. So we had an even harder job at keeping everyone to time, but we kind of did it. And was really delighted. We had it in Dumfries, so we really wanted to shine light on all the great work that's been done in Scotland. And we had the minister opening the event as well. So it just kind of shows you the profile that everybody here in this room and the kind of community over the last sort of decade or so have really raised the profile of all these coastal habitats to the point we have a minister taking time out to open a salt marsh conference, which was something very niche not so long ago. So what I'm going to do, I've just taken slides from different talks just to kind of shine a light on some of the people and some of the research that's been going on in salt marshes. And I was going to start with this one. You've already heard about SMEF this morning, and is really driven through the Scottish Biodiversity Strategy. And what was really great about this, they've now got this programme for coastal restoration in there, and habitats, and they've got the framework there for sort of habitat creation, which is great. And if you go on the website, you can see this sort of restoration tool, which is really starting to kind of bring people in to from developers, local authorities, and sort of restoration practitioners coming into the sort of Scottish government's Nature Scot sort of framework for restoration. And so I'd encourage you all to go and have a look at that. And then within Scotland as well, there's this great project, SCAMP, which is about restoring the coastal habitats on the north bank of the Solway. So it's the Scottish side of Solway, and it's this enormous piece of coast where there's lots of sort of, even though it's quite remote, there's lots of kind of issues there, lots of rural communities, lots of changes over time. And I think they're waiting for, I think there's going to be about a £2 million investment in SCAMP. They've been waiting for it a while. I think that's going to come up this year. And that's investing in the usual seagrass, salt marsh, oyster work. But what's really great about this, they're looking at dunes and coastal woodlands as well. We talked earlier, we've heard about Roger's talk about landscapes, seascapes, we talk about hullscapes. Where we are in our sort of coastal work, we must remember we're kind of that land-sea interface as well, and there's kind of rare habitats along there. So that's loads of great work going on within SCAMP, and I'm sure you'll hear much more about it in the years to come. And last year we had our Saltmarsh Forum. The Crown Estate held it for us in London, their London offices. One of the conversations we had there, we've got lots of evidence around. Lots of us, most of us are funded by public money, and we've got lots of experience with reports. But how do we get that up to the agencies, who have small teams essentially dealing with real life problems, making decisions? And Louise Denning from Natural England has done a great job in talking with the devolved agencies and bringing together their evidence gaps or evidence needs. And there's just an example there. I think there's 170 they came up with between SNH, Nature Scot and Natural England. And Northern Ireland, they're just kind of going through some change at the moment, but they're going to be putting their evidence needs in as well. And what we're going to do is the Graham's UK Blue Carbon Evidence Partnership are going to host the evidence needs for the UK agencies. And we're just going to work out at the moment how that's going to work and how we can start, getting those needs out there to this community, and then how we can get that fed back up. So watch this space, but we're going to start working over that, and maybe next year we'll be able to announce how that mechanism's going to happen. And then we all know about salt marsh creation in the Netherlands and the Wadden Sea, and the work that the Dutch do on their polders and sediment fields. And it's been tried here over the years, on and off, without not that much success. But NRW have got this project now in the Severn, on the north bank of the Severn estuary, where they're going again for this for polders and having these sediment fields. They've done really good consultation and really looked and taken some advice from the Dutch as well about how they do it, to try and stop sort of erosion on that north bank there near Newport. I think Hannah Mossman and Jonathan Dale are here today if you want to know more about that. And they're really investing in the monitoring as well, which has always been one of the things with these kind of polder works, that they've just been put there in there and hope for the best. So it's really interesting, exciting new method of salt marsh restoration that has kind of been tried, but not to the kind of scale that these guys are doing at the moment. And then the big topic, we've heard of salt marshes throughout today, and carbon's come up a lot. And the kind of what drove this really was carbon and salt marshes with the kind of the targets for net zero, and the Committee for Climate Change saying that the British government should consider salt marshes and seagrasses as inclusion in the greenhouse gas inventory, which kind of does our sort of national determined contributions. So the Environment Agency commissioned UK CH to put this roadmap together, and DEFRA Environment Agency, on what would it take and what are the evidence needs to get salt marshes included in there. And this route map has been published now, and you can see from the start it goes from red to kind of where we are at the moment, just sort of setting things up, through to green. And to get it included in the greenhouse gas inventory, it needs sign off by a minister. So there's all these steps we have to go through to do that, and it's all about evidence. It needs evidence all the way through. And we held a workshop last year, and think it's UK as well. And so we held a workshop last year, trying to understand the different definitions of salt marsh as used by the different country agencies, because every agency has a different definition for a different need or different reporting. So to bring all that together, and we found that with WFD when we were doing that 15 or so years ago, it didn't really suit each country's reporting needs. So there's been a bit of work done there as well about defining salt marshes for inclusion into the greenhouse gas inventory, and then how do you measure? And Nigel talked earlier about plants are the thing that draw new carbon out of the atmosphere into soil. So there's been a bit of work done as well as how you can actually measure tier 1 to tier 2 emissions through remote sensing. And then the Salt Marsh Code, I'm sure everyone's interested in that. Phase 1's over now, going into phase 2, which is moving towards operationalisation of the code. So there's testing at the moment of the draft code, then it's going to be refined, and then for the code to run, just like the Woodland and Peatland Code, there needs a whole governance structure to kind of administer the code, and that's kind of being worked out at the moment. And then there's obviously the business plan and financial model as well. And all that takes a lot of time, and it's a lot, all those kind of moving parts have to be put together. And the idea is that in the autumn this year, there'll be an open consultation on the code. So date to be confirmed, but look out for that, and we'll announce it. We can put it through ReMeMaRe, and there's an open consultation to everyone see how it works, to question, to understand it. So it'd be really great. Look out for that, and please come along and join that consultation, just to make sure it works properly. And the other thing is the monitoring and evaluation. There was a whole session on carbon monitoring. Loads of people in their different places around the UK are measuring carbon in salt marshes. And as part of the Saltmarsh Code, there needs to be MRV, monitoring, verification and reporting. We heard from Aviva how important it is that everything's credible. But to be credible, you have to have monitoring, and monitoring has to have standards. And what we heard in the Saltmarsh conference is that some people take cores to 10 centimetres, some to 50 centimetres, some to a metre. So if you are looking at carbon, if you are taking cores at your site, you may be really interested in your site, but think about how your work can contribute to the kind of the bigger picture, to the greenhouse gas inventory, to the code, and please get in, and there's appeal from the Carbon Code guys to get in touch so we can standardise those monitoring and measuring methods. And that'll come, and there's also some work by WWT and MMU which are leading on this, and that'll be out later, and you'll be able to see that in the autumn as well. And then this, Graham mentioned the connector SIG, and this came out of the connector SIG. We're thinking, what else do we need for Saltmarshes? What other evidence needs are there? And the Saltmarsh Code is just for managed realignment at the moment, because that's where all the evidence is, that's where everyone's working. But we've got this project now to think about other methods of restoration. You can invest £20 million in a big managed realignment, but what if you haven't got that much? And it also takes 5-10 years from sort of inception to delivery of those huge projects. But if the smaller, easier wins, how do we go about verifying and understanding what that is? So Blue Marine Foundation have funded a bit of work which Graham, Underwood and myself are doing to look at other methods of saltmarsh restoration, and the teams are out there at the moment understanding the methods, the drivers behind that, and what sort of goods and services they might deliver, including carbon as well and biodiversity. So if you've got any projects, I know that sort of buds and these matting is becoming more popular now. Get in touch, have a word with Graham and myself, and we could, if possible, we'll come and visit your site. We're going around Britain sort of assessing different methods at the moment and how well they're working. But it's not all about carbon. The next thing we've got to think about is, on the agenda, is nutrients. We all hear about pollution in the rivers at the moment, sewage, with there's nutrient neutrality laws in there, coming in, or they are in at the moment. But how do coastal habitats respond? We know salt marshes have the highest critical load of any habitat, and that's basically, you can dump lots and lots of nutrients on there, and this community doesn't switch until the thresholds are really high. So they can basically, because they're in this open system. So we've been doing work with the Environment Agency, looking at denitrification, and it's kind of looking at the moment that salt marshes are quite good at processing nutrients. We've done some work on, so that's high, middle and low salt marsh. Also got mudflat and seagrass in there as well, just for comparison. And we've also done work with Natural England, a review, looking at how salt marshes respond to nutrients in nutrient nodes and what the consequences might be of that. Because we don't want to sell, and again, if things work out, that could be a nutrient unit to go into the salt marsh code, to note it's a salt marsh code, not a salt marsh carbon code. So we could add on a nutrient unit or a carbon unit to that. Salt marshes, this Kai lad's work, salt marshes, if you look in the north of that, the line from the Solway to the Wash, they're kind of expanding and doing okay, but in the south and the southeast, salt marshes, they're degrading, sea level rise, increased storminess, they're degrading. We've got good evidence for that now. One interesting talk we had on looking at carbon dating is that sea level rise, salt marshes can keep their head above water when it comes to sea level rise. So they keep the sea levels going up, sediment goes up as well. So there's that extra layer of mud on top, but with carbon in there. So that's one thing. But if you look at that right-hand graph there, you can see there comes a threshold of about 6 mil a year where they can't keep up, where the sediment isn't there, and it tips over that threshold, so they start drowning. And that was Roland Garrett's work from Europe, which is really interesting. And in the south and east, they're really struggling to keep their head above water. And that's really good work we've seen there. Grazing, salt marsh grazing, the RSPB have doing a lot of work on that, and basically redshank breed on salt marshes, and salt marshes are grazed by cattle to facilitate redshank breeding, but the cattle go on at the same time the redshank are breeding, and they come in the same areas. So the RSPB have been doing a lot of work and understanding grazing regimes, timing, and they've got this sort of a conservation advice pack now for graziers and managers of salt marshes about how to manage this ecological trap, as we call in it. And then there's natterjack toads on salt marshes. We had a little talk about that. Public perceptions. This is quite intimidating. Smiling, creeping to the wall. Yeah. Social science. We haven't really had much talks about that today, but we had a really great session from Julia, which led by WWT and Julia. I think they've got about WWT got about 7 social scientists now, and it's kind of that perceptions. And Lucy here showed us some work on what people think about salt marshes and how they understand them. And I was quite surprised that 26% of people answered didn't know when they thought about ecosystem services, which means 74% did, which I'm amazed at, because I'm surprised that many people actually did. So I think it's quite a good thing. But there's a lot so there's a lot to unpick there in the blue health and all that sort of stuff as well. It'd be really, I think we should really try and make more emphasis of that sort of cultural, social value of our habitats. Then two more things. The breakthroughs. So the United Nations have these 2030 breakthroughs, which basically look to, by 2030, genuine changes in behaviours for climate change. And there's all these different areas they work at. And you can see their coastal oceans. There's been a mangrove breakthrough, which is a commitment by global governments for £4 billion worth of funding to restore mangroves. The seagrass one's under review. We're thinking of looking into a salt marsh breakthrough. And I think this would be really powerful because it just gives another hook for salt marshes and governments internationally, another driver for salt marsh restoration. And lastly, something that we're proud to announce today and launch today, really, and Jo talked about it, and Jo will follow up the last talk of the day, is this seascape restoration, this report. So Jo announced it last year that we all here, so Pip, Jo, myself, Bill, we're all working on our different habitats, Graham on Mudflat as well. What we really want to start doing is working together. We've been so focused on restoring our own piece. What are the interactions between our habitats? And then if we understand that, then we can sort of push towards seascape scale, large scale restoration. We all know what landscape scale restoration looks like, trees and hedgerows and fields and connectivity. We don't really know what seascape scale looks like. So Jo's going to talk about that in a lot more detail later. But I just want to thank Aisling, who's there at the back, and Blue Marine Foundation, who've done a brilliant job in getting it over the line. We were working till last night to get this report released, and there's a QR code. So if you get your phones out and look at that, you can go and look at the report. We're going to kind of soft launch today. If there's any comments on it, we've already given it to the ReMeMaRe team. We really want to kind of make it something that we can push across the table, give to policymakers, give to funders, and drive large-scale ecosystem, seascape scale restoration in the UK. Thank you. Thank you,
I was told to be very strict on the timing, which is why I'm lurking in this intimidating fashion. But thank you very much. I couldn't stop Angus talking about the Seascapes report because it was the ink is still wet on the paper. Yeah, we got some paper versions, so do have a look at that, everyone. Thank you very much. So. Great. Now we welcome up Pippa Moore from the University of Newcastle. Oh, no, we don't. It's Bill. Sorry, beg your pardon. Bill Sanderson from Heriot Watt, going to tell us the latest in the world of oysters. So, Bill, thank you very much.
Okay, thank you. So I'm going to be talking today about where we're up to with oyster restoration in Europe and where we're going to with it to get to scale. I've dubbed this with the movie title, Everything Everywhere All at Once, but we will get back to that later on. My co-authors in this, there we are Joanne Preston and Feline Zoemkerson, both of whom have been very much involved in large-scale restoration projects over the last decade. And Feline has worked in the US before she started doing her work in Europe. So what I'm getting at really is, I suppose we've all been in it since the beginning, and this is a bit of an opinion piece as we're going through. So for my own part, the Dornoch Environmental Enhancement Project is one that I've been involved in for 10 years. We've had to go through these different stages: former presence, the survival of oysters in the present-day system, optimizing the process of restoration, and then now moving to scale and dealing with those aspects. The other big project I've been involved in, sorry, I should have said Glenmorangie sponsored the previous one, and the Marine Conservation Society are a key partner. In this project, which is managed by WWF, this is Restoration Forth, which we're very involved in as well. We have many other partners in this project, and it's a consortium. It's been running for as little as 3 years, but it's very interesting in the way we've been trying to engage with communities, and it's integrated, and it's got salt marsh in there as well as oysters, and we're trying to influence the policy landscape along the way as well. I'll take you back a little bit. You're probably used to seeing this picture by now. This is Olson's wonderfully named Piscatorial Atlas from the 1800s, where he interviewed fishermen and then drew out where all the abundant oyster habitats were. Just to put it in perspective, where I came from yesterday, Edinburgh, the Firth of Forth used to have an oyster bed that was about 300 square kilometres, which is about the same size as the modern-day city of Edinburgh. All of that is gone, and all of these habitats, mostly on the screen, are all gone as well. And this means that 10 years ago, when we started out with our projects, myself and Joanne and Feline, there was very little activity around oysters, and that's now grown considerably. We're seeing 30-plus projects, 2 or 3 new ones every year across Europe now. We've seen the UN Decade come in on restoration. We've seen the EU Nature Restoration Law come along as well. So things are hotting up and things are speeding up. This is a bit of an old analysis, but it nevertheless is sort of fairly true today still, and that is that most oyster projects around the world are quite costly, about $10,000 US to $100,000 US per hectare. And also, most projects are very small. So we're all very good at projecting our projects, but when you actually scratch the surface and look underneath the bonnet, they're all quite small. Most of them are less than half a kilometre squared. So that leads me to my first of 3 major sort of like themes in this talk, and that's ambition. If we look at Olson's Piscatorial Atlas, and we look at a very recent analysis that's about to be published by Ruth Thurston and Joanne and Feline as well, we found that the actual record, you might be excused for thinking Olson might have gone a bit wild with his crayons in the 1800s, and that there might not be very much truth in those marks across the map. But actually, when you look at all the individual records and positional information, and you go trawling through all of the really old literature, you can find that actually all the records kind of back it up. That means that we're talking about quite large habitats, and ecosystem recovery must be meaningful at scale if we're going to really sort of push beyond and to start doing oyster restoration at scale. So if we think about many of these sort of policy documents, we often see self-sustaining ecosystems as an aspiration in those sort of things. In the EU Nature Restoration Law, we see an aspiration for 20% of EU's land and seas to be restored by 2030. We see marine habitats directly mentioned in there, and that aspiration applies, of course, to things that we're involved in restoring. So if we start thinking about, what 20% of the former oyster habitat might look like, well, in that report in that paper that Ruth Thurston and co are going to publish very shortly, we're talking about something like 1.7 million hectares of oyster habitat that used to be in the European waters. Okay. Now, just to get that into some sort of perspective for you, if you took 20% of that, that'd be about, I'm just going to move units to kilometres squared because I work better in kilometres squared. That's about 3,500 km squared. So if you build a bridge that's 410 kilometres to Amsterdam from here, and you build your bridge 8 kilometres wide, that's about how big the restoration work we're talking about at 20%, okay? That's enormous, okay? So the historical extent, of course, is never necessarily achievable in the modern context. We've changed the use of our seas, there are other competing activities, but ecologically, informative references like this is really interesting when you start thinking about, what restoration at scale might look like. And I'm going to use an analogy here to sort of illustrate one of the points that comes out of this. Oysters are sort of, they aggregate in large numbers in certain habitats. They're also planktotrophic larvae, which means that they can feed in the plankton, they can carry on chugging until they find somewhere suitable, or they get eaten by something, okay? And also they're predominantly subtidal species. Now there's another habitat type that's just like this, but it's a northern variation on the oyster habitat, and that's the horse mussel habitats, which I spent a lot of years on as well. And horse mussel habitats look like these pictures on the right-hand side. And if you study horse mussel habitats, there are still quite a few of these left because we never directly targeted them for fisheries in the same way as we did with oysters. So there's still some left, okay? If you look at this work by Clara Mackenzie, then the horse mussels that we sampled throughout all these different locations, sometimes you find genetic similarity between populations that are 10 kilometers apart. Sometimes you find genetic similarity between populations that are hundreds of kilometers apart. And sometimes you also find very low levels of similarity between populations that are 10 kilometers apart and low levels of similarity between populations that are hundreds of kilometers apart. And that's because there's lots of stochasticity. There's lots of random chance in where these things land. They go off into the plankton, they drift about, they get pushed around by the waves and the currents. Sometimes they get eaten up in the plankton, and sometimes they land out. So you get connectivity between populations over time and over space. So what I'm saying is if you take something like the North Sea and these open oyster restoration sites, and this goes back to the everything everywhere all at once thing, then we're not going to restore oysters in the long term until we restore networks of oyster habitats throughout their former range, okay? Which means everything's got to work at the same time, all right? Now let's start talking about practicalities. There's supply chain issues in oyster restoration. We've got a few hatcheries across Europe. I'm pleased to say we've got a couple of them represented here today. We've got a few growers that are growing native oysters as well. But it's fair to say that we don't have a consistent, continuous production going at the moment, which means that the supply chain is a little bit fragile. And that means that many restoration projects in the past have relied on growing oysters on aquaculture sites like my projects, and then moving them across from the west coast of Scotland to the east coast of Scotland. That attracts large amounts of biosecurity concerns because you don't want to create the own goal where you transfer an invasive non-native species and wipe out your site and somebody else's livelihood at the same time, okay? That means that when I'm moving 5,000 oysters, we have lots of volunteers involved, but it takes 50 hours of effort to clean them all up to make sure that we can move them to the restoration site, and that's not scalable. We've moved over 130,000 oysters so far in the work that I've been involved in, but we need to be starting to do that routinely year on year. So how do we do that? It's not scalable at the moment. We need to be doing much bigger movements. And that means a lot of people have started to think in their individual projects now about localized production, small-scale hatcheries or grow-out operations, and actually producing oysters on site so that you can bypass some of this biosecurity work. Because if you move the larvae from a sterile, a clean hatchery location, you can move millions of larvae in a teacup, and you can move them to your site without any real requirement for biosecurity. And then you can set them onto shell, or you can put them into on-growing operations, and then you can grow them on your restoration site. So there's big changes required in the way we do things and the supply chains. Scenes like this, this comes from the US, from Chesapeake Bay. We need to restore habitats, so we need to get into a lot more marine logistics at scale as well to be able to restore some of these habitat types. And if some of you are beginning to get a bit freaked out about the expense of all of this, then I'll reassure you by saying, well, actually we can drive down expenses. This little project here that we did is actually bizarrely on a worm type, a reef-forming worm on the west coast of Scotland, which is another protected habitat feature, but it also has a planktotrophic larvae. If you put the substrates out at the right time, or if you put the substrates out in the right place, you can treble the number of actually larvae that settle out and grow on it, which means that you can effectively drive down the costs of restoration work to a third just by doing things in a smarter way. And here's some more examples of this as well. So this is some work we did on oyster larvae. And what I want you to take from this, lots of different options for the larvae to settle onto. But what Ana Rodriguez's work showed was that if you offer them a stone that came from an oyster site, then they would start to settle. And you can see that on the right-hand side, yellow dots there, they start to settle and settle out. If you offer them a stone that doesn't come from an oyster site, they don't do that. And the reason is probably there's some sort of biofilm involved. There's a sort of, they're recognising the fact that it's an oyster site. And the thing that really triggers them, which is the dots on the left-hand side, if you put another oyster down there. So what that means is, if you're going to put habitat down on the seabed, if you pre-seed it with oysters, then you're going to draw the larvae down onto the seabed. That's going to massively increase the efficiency of your restoration work. So there are other examples as well. You can do this. We did some more work looking at understanding the timing of oyster larvae in Loch Ryan, because that's our last remaining wild fishery in Scotland, in Loch Ryan. And the larvae there are in the water at certain times, but if you count the number of degree days, the number of degrees over 7 degrees, which is when they start to mature their gonads, and if you count that up over time, there's a magic number. And when you get to that magic number, you can predict when the maximum number of larvae are going to be in the water. If you can do that, you can time when you put the culture in to restore the habitats, and you can massively increase the efficiency. So what I'm saying is we've got a lot of work to do on driving down the costs by improving the efficiency of oyster restoration. We also, and we've been hearing from other speakers about understanding the business models behind restoration, why people might invest in them. And there's still work to be done here in this area for oysters as well, because if we can improve our knowledge of the outcomes for investment, then we can attract the money we need to do these things at scale. So we've got this wonderful diagram from a piece of work that Joe led for restoration. We know that oysters have got lots of ecosystem services associated with them. They enhance biodiversity, they soak up nutrients, etc. Okay, so if we can clarify those business models so that you know exactly what you're going to get out of it for the money you put in, that's really important. I'm getting the signs right. Okay, so it's costly, so we can drive down. Yep, okay, but don't be afraid, folks. We're not shy of spending money in the marine environment. You know, there are wind farm projects out there at the moment which are several millions of pounds worth of investment. When we know what the costs are and we know what the benefits are and we can see it clearly, we can drive this sort of investment process. So, as we know from Joe's work in the Solent, we don't value yet all of the ecosystem services properly in the marine environment. In the Solent example, there are billions of pounds worth of habitat ecosystem services, which are soaking up nutrients and storing carbon. But once we get to the point where we properly value those, I think we can drive the investment much more clearly. We've got clarification of some of this in the work that Hannah Lee did. I'm just skip over that slide. But what I will say is that when you look at the carbon budgets for oysters, and you look at how much they put down in the calcium carbonate in their shells, and you compare that to how much they poop out onto the seabed and draw out of the plankton, that's the carbon they're locking up in those habitat types, but they also respire whilst they're doing it. And they almost do as much respiring of carbon and produce as much carbon as they actually fix onto the seabed. So it's not going to fix climate change for you, but it is going to make carbon stores, and that's where we have to start looking at the bigger pictures. From a biodiversity point of view, there's some work here by Naomi Kennan, and she's been looking at how fished plots recover in Loch Ryan. And if you look at that recovery curve, it's very analogous to the increase in biodiversity that we might get from a restoration site. And from this work, we start to see that you might see a doubling of diversity in a decade with oyster restoration in those areas of the seabed. So overall, I'll say what we've got to do is we've got to drive up the ambition of what we're doing. We've got to increase the practicality of it along the way, and we've got to drive down the expense. Okay, and I think it's timely to have this conference and to make these points. It's ecologically valuable for us to do this. Technologically, I think it is feasible, despite the problems I've put before you, for us to move to scale. And I think if we tackle ambition, practicality, and drive down expense, we'll get there. So thank you.
Very good. Thank you very much. Thank you. So now it's Pippa Moore. Beg your pardon for introducing you earlier, Pip. So Pippa Moore from the University of Newcastle, who's going to talk us about wild, restored and farmed kelp.
Yeah, not what it says at the moment. Oh,
Here we go.
no,
It does now.
does now.
Yeah.
Excellent. So some of you might be wondering why we haven't heard lots of talks about kelp restoration today. And part of the reason for that is actually kelp is, on the whole, a good news story in the UK, and it doesn't need to be restored. So I'm just going to talk to you today about the sort of state of kelp forests in the UK, and also the ecosystem services that they provide. So this is some unpublished work from Mike Burrows, looking at habitat suitability modelling to look at the spatial extent of kelp forests. So we've got two main species of kelp. We've got Laminaria hyperborea, which you find on very open exposed coastlines. And we've got Saccharina latissima that you find in more sheltered or tidally dominated habitats. And it's also the species that's predominantly used in aquaculture. So we have about 2,500 square kilometres of Laminaria hyperborea. And we have about 1,300 square kilometres of Saccharina latissima. And if you look at all of the kelps that we have 8 different species, is that adds up to about 5,700 square kilometres. And if you can turn that into standing stock, that's about 11 metric tonnes of fresh tissue. Interestingly, I looked at the Crown Estate document that was talked about today, and I did a quick back of the fag packet maths, and the maths adds up with what they were saying, so phew. But what this means is that actually kelp forests are our largest marine vegetated habitat in the UK. We've got the spatial extent of kelp forest is 9 times greater than Saltmarsh and 30 times greater than seagrass. So they're a really important environment. We're also seeing the expansion of seaweed aquaculture in Europe. And you can see that since sort of 2017, you've got an exponential rise of the amount of seaweed that is being, or kelp that's been harvested in Europe. But you can see that it still counts for very little of the actual percentage of aquaculture globally. It's less than 10%, but it is increasing. In the UK context, our first seaweed aquaculture farm was established in 2016, and I've got to learn my lefts from my rights now. On the left-hand side, what we've got there is the sort of cumulative approval of licenses over time, and you can see that there's actually been a fourfold increase in the number of applications. The asterisks are the mean number, or the number of applications made each year. Obviously, applications doesn't turn into necessarily farms, but that's the data that we had, and Maxine Canvin, one of my PhD students, has just written up a nice little review about this. Most of the seaweed aquaculture in the UK is used for food, feed, and cosmetics. And we've also heard today that the potential for co-location of seaweed aquaculture with, say, offshore wind, for instance. And this is some work from another of my PhD students, Ethan Clark, and also Rodney Foster is involved in this work, looking at habitat suitability of aquaculture co-location with offshore wind. And so the greener and yellow and the greener colours, so that it's better, there's a greater proportion of it being suitable, and the sort of red colours indicate that it's not too good. So we can see where a lot of the aquaculture is being developed in the North Sea is it's grey and it's not suitable. And the reason for that is the significant wave heights are just too much for the species. This is Saccharina latissima, it's too much for that species. But we can see, for instance, I'm going to not say it properly. I hope no one's from an NRW here. Gwynty Moor in the north coast of Wales. I should know how to say that. I've done research there. But actually is highly suitable for farming Saccharina latissima. But like with so many of the habitats that we have globally, kelp forests are under decline by a range of threats. Marine heat waves, decadal scale climate change, introduced species, over-harvesting, and this, you've got a map here showing where you've seen those impacts. And this has led to a decline in the amount of kelp forests you find. There has been increases in places and decreases and no change, but overall, if you look at the sort of left-hand bar graph, is that overwhelmingly it's red, bad, not blue, good. So we're seeing declines, and as a function of that, and in terms of a UK context, I've already said that actually the UK is generally a good news story when it comes to kelp, but there are areas where we have seen sort of small-scale regional decline. So many of you will be familiar with the Sussex kelp project where they put in the trawling ban to reduce the pressure of trawling, and probably more importantly the sedimentation that occurs as a function of that trawling, to try and stimulate the recovery of the kelp forest along that Sussex coast. The bottom set of pictures is from the Durham coastline, and the picture with the black all over it is a beach called Easington, and at that site the coal mine there would just dump its coal spoil directly onto the beach. I think some work that was done in the early 1980s suggested there was N equals 3 species on this shore because it was just totally covered in coal waste. In the 1990s they did this amazing project, I think it was called Turning the Tides, along that coastline. They spent millions of pounds taking that coal up, and actually the picture on the left here is actually what it looks like today. When I first moved to Newcastle about 4 years ago, Durham Heritage Coast came to me and said, Pip, we'd really like to pay for you a PhD student to do some restoration at this beach. We went down to that beach at low tide, and lo and behold, it didn't need restoring, it had made its own way back, which is great. You know, that's what we really want to do. As Bill just said, restoration is expensive. So while we've done, the PhD student instead looked at the sort of the health of that system compared to non-disturbed systems, is that there was natural recovery at this side. So we do have some regional declines, but kelp is declining globally, and as a function of that, there has been a lot of effort started more recently. In terms of kelp restoration, it's way behind oysters, saltmarsh, seagrass, because it just has perhaps started to disappear more recently. So there's been a lot of effort done to look at different methods of restoration. As Bill said, all of these methods that have been, for oysters, the same applies for kelp. All of these methods have been relatively small scale, really expensive, and in the case of probably kelp at the moment, with the exception of 1 or 2 efforts, is being research-led rather than community-led or organisation-led. So the image I've taken here is from a green gravel network. The idea of that is that you seed kelp onto bits of gravel and you can just throw it out from the boat to try and make it less expensive. We've actually done some proof of concept stuff of that off the Newcastle coast, and we're working with the fishmongers to actually do this in southwest England and up in the northeast coastline around Easington and Blast Beach, where the images I showed you earlier, to show that proof of concept, so we can show whether or not it works if in the future we do see kelp forests disappear along this coastline. So one of the things I wanted to, this story sort of has a story of 3 halves, or three thirds. Is next I want to say, you know, why are kelp forests so important? You know, I bang on about kelp forests to my undergraduates to the point where they do enjoy them. Whether or not they enjoy it more than coral reefs, we're yet to see, but I do try and sell them a much better place to dive. You don't have to worry about things too much. So kelp forests, like all of these habitats we're talking about today, have really a whole load of ecosystem services. So in terms of supporting services, kelp forests support high levels of biodiversity, they provide habitat, they cycle nutrients in terms of nitrogen and carbon. I'm going to talk about carbon in a little bit more detail further into the talk. So the kelp holdfast, which is sort of like the roots of a tree, and they provide a habitat that can support up to 50 different species. A kelp plant itself can support up to 80,000 individuals, so they support highly biodiverse systems. They then create a habitat that supports a really rich algal assemblages beneath them that also has a whole rich fauna within them. And this, of course, brings in fish and crustaceans that eat these things. Many of these are commercially important, and kelp forest acts as important nursery habitats. And this also then attracts higher order predators such as otters, seals, seabirds, and cetaceans. A study I was involved in recently looked at the sort of, tried to value the ecosystem services of the fisheries and also the nitrogen, and it was shown that actually kelp forests the amount of nitrogen cycling is about 74,000 pounds per hectare per year globally. And for the species that we have in the UK, our two main species, it's even more, about 113,000. Perhaps a small caveat to that is I'm an ecologist and don't really know what goes on inside the kelp. But if you talk to people who are really knowledgeable about sort of nitrogen dynamics, there is a debate in terms of the nitrogen cycling, whether it's just nitrogen in, nitrogen out. The caveat or the exception to that potentially is if you're using it and then harvesting that nutrient uptake and getting rid of it somewhere else. We also know that seaweed aquaculture, while there's been very, very few studies looking at the biodiversity value of seaweed aquaculture, is that we know that it does support higher abundances of invertebrates compared to native kelp forest or natural kelp forest, but much, much lower diversity. They're dominated by amphipod species and none of the other rich diversity you find in kelp forests. They also provide provisioning services such as fisheries. So again, in this study that we were involved in, it was estimated that kelp forests in terms of fisheries contribute about £30,000 per hectare per year globally. And for the species that we have here, it's again a little bit more. There's a lot of variability around that, but it's about £33,000 per hectare per year. Early work in terms of seaweed aquaculture suggests that actually these aquaculture facilities do support commercially important species, probably less diversity, and because of the nature of aquaculture, harvesting cycles at the moment is very seasonal, so it's not, it's for that period of time, that 5 or 6 months where you've got a canopy in that system. They also provide regulating services such as coastal defence and I'm getting really twitchy every time you look at your watch. Flood and coastal defence. This is an image, okay, brilliant. This is an image from Warburth in Scotland showing a great extent of seaweed forest. And we can show with hydrodynamic modelling that actually if you have higher plant density in shallower water, and when you've got a much denser canopy, that the wave attenuation is dropped down by seaweed aquaculture. And I think Karen Daglish is speaking in a little bit time about the Stronger Shores project, which is looking to actually measure these things. And we've got 3 PhD students here today who are doing various aspects related to this to really try and get a handle on the wave attenuation. And then there's always one for a fluffy, the cultural services such as recreation. If you go up to the Farne Islands and dive in the kelp forest, you'll no doubt be attacked by a seal wanting to rip your fins off or something like that. So one of the things I wanted to focus on just in this last part of the talk is the importance of kelp in terms of the carbon cycle. Kelp is incredibly good at drawing down carbon and turning that into biomass. In places off the South American coastline, the productivity of kelp is the same as the Amazon rainforest. The average productivity of kelp is similar to broadleaf forests, so they're incredibly productive environments, and we can see that level of productivity there. They are really important in carbon cycling because they take that carbon, turn that into biomass, and the way that they grow means they're always releasing carbon into that water column, either as small particles at the end of their fronds or as wave action ripping them up. And they go on to be important in terms of food, but also potentially carbon sequestration. So we've estimated for the UK, for instance, that between 160 and 500 grams of carbon per metre squared per year is lost out of kelp forest, of which 90% of that actually leaves the kelp forest itself. But where does it go and what does it do? Some of that is going to be immediately remineralised and turn back into CO2. Some of it might end up in the deep sea. And so this is some stuff that's pretty hot off the press. It came out about 2 or 3 weeks ago, where we did some modelling work looking at seaweed forest habitat extent, the productivity, decomposition rates, and transport rates. And it's estimated that seaweed forests contribute about 4 to 44 teragrams of carbon per year, which is sequestered in the deep sea, so below that level where it can't be remineralised again. Similar studies have shown this as well. Oh, the Grim Reaper's coming. But from a UK context, actually the amount that's sequestered is about 0.66 teragrams of carbon per year. And that's only about 5.4% of the actual productivity from our kelp forests. We can look at the same with seaweed aquaculture, and this is some work done by Maxine that's showing that there's sort of, I can't read that, 0.014 I'm aging, tons of carbon per hectare per year is released. So the amounts of carbon released and potentially sequestered are really small because seaweed aquaculture at the moment isn't optimised to capture carbon. We should perhaps think about other reasons for it. So, very quickly, kelp forests are UK's largest marine vegetated habitat. They provide a wealth of ecosystem services, but we need to be really careful that we don't overdo how important kelp forests are. I love kelp forests, okay? But, yes, kelp forests can sequester carbon, but actually at a UK scale it's probably relatively small amounts because of the distance away we are from the continental shelf and the seasonality of seaweed aquaculture. Seaweed aquaculture systems support a wide range of assemblages, but they're less diverse and less even, and probably in a coastal zone support invasive species. You hear lots of discussion about co-location, and I've heard people talk about it as a biodiversity net gain, and that gets me a little bit worried. If I'm putting seaweed aquaculture and co-locating it with a wind farm, that is not where a kelp forest has ever been. Okay, you're moving something that's found on the coastal zone into something that's generally over a soft sediment habitat. And I sort of worry about that in terms of the idea that that's net gain. It's an introduced species effectively. UK kelp forests are in a healthy state, but we do need to do preemptive conservation and management because they're critically important habitats. And seaweed aquaculture has huge potential, but I think we need to focus on direct uses rather than focusing on other parts, but just thinking of those as passive benefits in terms of biodiversity and carbon sequestration.
Thank you very much, Pip. Really great. Great to see that Philby Dexter paper out at last. Yeah. I saw that in a conference a year and a half ago, still under review. So brilliant. It's a really wonderful piece of work, that is actually, in the Nature Geoscience. So excellent. Right. Last but not least, still only 15 minutes, so Joe, is Joe Preston from the University of Portsmouth. I'm going to talk around the ecological connectivity work. So, Joe, thank you.
Did I just press the green button?
Yeah.
Oh, yeah. Thank you. Great. Well, it's so wonderful to be here and see an ever-growing mass of restoration and habitat and conservation fans. So I'm going to talk about ecological connectivity across the seascape. Our coastal areas are made up of mosaics of habitats, and it is the connectivity between these habitats that support coastal trophic food webs. And this is of relevance for our global restoration targets, particularly the coming Montreal Biodiversity Framework and particularly Target 2, that asks us to ensure that by 2030 at least 30% of areas degraded terrestrial, inland water and coastal and marine ecosystems are under effective restoration in order to enhance biodiversity and ecosystem functions and services, ecological integrity and connectivity. But if we don't know what that connectivity is, we've got a bit of a problem. So last year I presented the proposed outputs from our symposium at the Zoological Society of London, one of which was the paper, and the other one was a report. And this was to really help deliver the aims of ReMeMaRe, the SIG connector, and also the decades. Now, I'm pleased to say that we've submitted the paper to Nature Ocean Sustainability, and the report's just been launched. And so today I'm just going to go through what we found around ecological connectivity. So what do we do? This paper, which is sort of the nuts and bolts and the meat supporting the report, first of all, it defines the consensus definitions of what we're talking about when we look at the seascape and connectivity. And then it provides a meta-review of all the existing evidence for connectivity across the biogenic habitats and mudflats. We identify priority areas to meet knowledge gaps, which I won't talk about today, but also we looked at the evidence of uplift of ecosystem service delivery arising from connectivity. And then we present a roadmap based on this connectivity to try and help achieve restoration at scale, some policy recommendations. And we frame this in terms of the triple planetary crisis of pollution, biodiversity loss and climate change. Now, seascape restoration is simply the restoration of multiple habits concurrently or sequentially to restore functionality and connectivity across a mosaic of habitats in a marine ecosystem. And there's lots of debate around ecological restoration and rewilding. We think they're both trying to achieve the same thing. So we describe this spectrum of ecosystem restoration which aligns with the decade, and we talk about that in the paper. Last year we presented a restoration statement, a seascape restoration statement, which is based on this evidence to really try and advocate approach of habitat restoration that meets the goals we're trying to achieve, that delivers ecosystem services and functions. That went out to consultation, and we've currently revised it, and it's on the screen here. I'm not going to read it out to you, but if you follow the QR code from the report that Angus launched, then you can read it there. And this is really, you can do what you want with this really, but it's just really to say that this is an ecological approach to how the coastal habitats interact. Now, ecological connectivity is really sort of thought about in the terrestrial environment, and the IUCN describe it as the unimpeded movement of species and the flow of natural processes that sustain life on Earth. And connectivity is essential if we're going to deliver on their ecosystem services on what nature-based solutions are depending on to solve our climate, biodiversity and pollution problems. It's often split into structural and functional connectivity, and we describe those, and then we also talk about the mechanisms. It gets a little bit complicated and messy, so we made a pretty picture. And these are all the examples of structural and functional connectivity in the marine environment. The orange is the functional connectivity, so the movement of things like larvae and movement of fish and spawning migrations. There's also the movement of organic carbon and nutrients. And then there's also the genetic and larval and seed movement. And this is connected to the structural connectivity underneath, which looks at the physical properties of the seascape. The mechanisms are the process by which these happen, either drifting or swimming, and then they deliver the ecosystem services. So that's a bit dry, so we made a pretty picture, and there's an even prettier version of this in the report. And I just want to pull out a few examples. If you look at the oysters and the algae, there you've got the area of the oyster reef. The structure will determine how much benthopelagic coupling occurs, which is the functional connectivity. And the mechanism by which that happens is filtration, and the ecosystem service it provides is increased water clarity and cycling of nutrients. So this is why it's so important. Another example is the distance between habitats determines the animal movement and how well they're used across a species' life cycle onto genetic uses, and this impacts biodiversity, nursery grounds of fishery production. And so we split the paper into these areas of structural and functional around these three themes. And I'm not going to go through the whole paper, I haven't got time. I'm just going to pull out a few examples. Now, the whole of the database will be available as supplementary information so people can dig into it. And I really hope we miss loads, and this will start the conversation about more data and more evidence. So what we also saw, this is where the data came from. So there are huge knowledge gaps around the biogeographic spread and source of this information on connectivity. You can see the hotspots of data are where there are hotspots or longer track records of ecological restoration, particularly the North Sea and the, in America and a little bit in Australia. So we're missing a lot of information. Now, the paper basically highlights the different examples of connectivity along these different aspects of biodiversity, nutrients and carbon. And what we did, we just assimilated all this understanding of connectivity of carbon across the seascape into a diagram. And I'm going to have to look at my notes for this because this was the work that was led mostly by Rachel Dunk and Emma Ward. And what we show here is the movement of carbon across the seascape. It describes which habitats have existing codes, which ones are being developed, and which ones don't have any plans to be developed. It also shows the receiver and donor and where those connections lie. Now, The reason why we did this is that when you start to look at single habitats and carbon credits, which are driven by the carbon sequestration storage and greenhouse gas removal properties, there are some really big problems. And you can only credit for the autochthonous organic carbon that comes from that habitat, and anything that comes in from outside you have to deduct. In a dynamic system that's completely connected and the sediment moves all over the place, that provides real challenges and things like greenwashing or blue washing. So if you look at those sort of, it doesn't come up. There should be a blue wavy line. So if you put a blue wavy line around the seascape, then it solves some of these problems. If you can look at blue carbon from a seascape approach, it's a more holistic approach. So first of all, the organic carbon contributions from multiple habitats can be considered autochthonous. It addresses leakage issues with hydrodynamically linked systems. It would recognise and confer credits to habitats that were organic, were donors of carbon. And it allows the inclusion of synergistic climate mitigating benefits from habitats co-locating. So that's something just a food for thought, really, when we understand this connectivity. Now, this is a very busy table. Basically, what we wanted to do, there's an increasing evidence base for the ecosystem services provided by single habitats. And what we've done here, we've gathered all that evidence and linked them across the different habitats of seagrass, saltmarsh, oysters, macroalgae, mudflat, merle, and mussels to their different ecosystem services, and we've linked them how they deliver on the Sustainable Development Goals. What you can see is there's lots of dark blue, we've got lots of evidence. So already, just looking at this, if you restore across the seascape and multiple habitats, you're going to get much more delivery of ecosystem services. There is, however, gaps particularly around cultural services and merle and mussels. But then we wanted to see, was there evidence where connectivity actually created an uplift in ecosystem service delivery, which wasn't as easy as it sounds. So we assessed the connected habitat types. The change in the ecosystem service was measured or inferred, the direction of the change, and the type of evidence. And each one of these grids represents a habitat. And if you look at grid D, near biodiversity, that's oyster reefs, D, and you can see there's a pie chart that has some negative, positive, and neutral change. And so what you see there, oyster reefs have an increase in crabs. Those crabs go and have increased predation on the mudflats. So it depends whether you're a crab or a clam fisher, whether it's a positive or negative interaction. So these are site-specific, but what you do see that most interactions are positive, but also there is no data for a lot of the interactions of how connectivity enhances ecosystem services. But it's a pretty cool overall sort of synopsis. And this was a much smaller subset of the 304 publications that we reviewed as part of the assessment. And then we took all this evidence of ecological connectivity on delivery of ecosystem service provision and put it into an infographic, which looks a little bit like a tube map. And I just want to go through some of them. And this is really to show to people how you can't restore habitats in isolation because everything is connected to each other. So you see in the light blue line, the wave attenuation increases and coastal protection increases due to the presence of multiple habitats. You can see that macroalgae or kelp can drift into seagrass meadows and offshore and increases the biodiversity associated with seagrass and other habitats. If you look at the light pink, the existence of multiple habitats supports ontogenic movement, so movement of species across our life history, enhances biodiversity, nursery function, and fisheries production. Now, we know this sort of intuitively, but now we have evidence to support this in one place. The dark blue tube line, that's the denitrification mediated by salt marsh, increased water clarity and primary production, and carbon sequestration in seagrass. Orange is the benthopelagic coupling of oyster reef, increasing carbon sequestration in seagrass meadows. And the dark pink is the presence of habitats increasing sediment stabilization when you have more of them. So if we are going to achieve our goals, our planetary goals, we really need to think about these interconnections. So because of this evidence, thank you, because of this connectivity, what does it mean? Well, I think it means that the seascape restoration, given the urgency of our crisis, is also timely and urgent. And also, when you're planning restoration, you need to think about connectivity. And you need to think about site suitability really early on and how this might change because of the flows between things. And particularly, you want to think about the order of your habitat restoration. We've had a lot about seagrasses. You might want to do your oyster and salt marsh restoration first to improve the water clarity to enable seagrasses. Restoration shouldn't be a separate thing. It needs to be incorporated into climate-smart marine spatial planning. And as we've said today, we need to really mature at scale. And therefore, we need restoration innovation to develop in parallel with our regulating and licensing environments. And this is what this community is doing so brilliantly. And this is a really important thing. We need to learn while we're restoring. So we need to align our research agendas and monitoring frameworks of restoration projects to increase the confidence in nature-positive financial markets and unlock some of that funding. So then we think about policy. And I'm not going to read all this slide out because I don't think I've got time. I've got 1 minute. But we flag up 3 policy pathways to help achieve this. And then we offer some key actions. And a few things I want to just highlight is we've got to acknowledge degraded baselines. And we also need to start to have some really good metrics around seascape connectivity and identify which the priority ones are. But you'll be able to read these on the preprint, which hopefully will be out in the next month or so. So, to finalise, Rachel Carson, an absolute hero of mine, in nature, nothing exists alone, and we hope this evidence really shows that. And Nelson Mandela, it's always impossible until it's done. And it's you guys, it's this community is going to show it's possible. And this infographic really demonstrates that fundamental relationship between climate mitigation, biodiversity, and how that is served by a restored seascape connectivity and complexity, and fundamentally our human well-being depends on that. Just to hold the date, next year we're going to have a second symposium at the Zoological Society of London that really starts to dig in more about understanding ecological connectivity across the seascape. So hope to see many of you there. Thank you. There's no time for questions, but anyway.
Splendid. Thank you very much, Jo. And she's pulled together a whole set of themes from today, actually, in that last talk. Many of the things we heard about today resonate in those final bullet points and things there that we haven't got time to read but are in the report and things.